Okay, guys, with this slideshow presentation, we're going to start talking about some of the introductory stuff in Chapter 3, okay? This slideshow will probably be broken up into two videos. The first video covering that, which is presented in the Section 3.1, the second video covering that, which is in Section 3.2. So here we are. We're going to start talking about angles that are formed when you have two lines being cut through by a third line. Okay? Now, the line that's cutting through the two lines L and M is what we call the transversal. So the transversal is a line that intersects two coplanar lines at distinct points. Now, whenever a transversal passes through two lines, we're going to have eight angles formed. Eight angles formed. Okay? So we're going to start identifying those angles by names, and then we're going to start looking at relationships that exist when the lines here, L and M, are parallel. Okay? But for now, let's just identify, okay, a transversal as a line that intersects two coplanar lines forming eight angles. Okay? A line intersecting two coplanar lines forming eight angles. That's the transversal, T. The angles are going to be identified by first tagging them as interior versus exterior. The interior angles, as you should well imagine, are going to be these angles that exist in between these two lines, 3, 4, 5, and 6. The exterior angle is going to be those tagged as 1, 2, 7, and 8. Okay? Then you have what you call the alternate interior, okay? Alternate interior on opposite sides of the transversal, okay, that are non-adjacent. Okay, so, okay, if we're tagging alternate interior angles, 3 and 4 are on alternate or opposite sides of the transversal T, but they are adjacent, so they are not alternate interior. 4 and 5 are what we call alternate interior because they are on opposite sides of the transversal, but they are not adjacent or next to each other. So the alternate interior angles that we identify whenever transversal passes through two lines, as depicted in this picture, the alternate interiors are going to be 3 and 6, 4 and 5. 3 and 6, 4 and 5. Okay? The biggest classification of angles in this kind of arrangement, that arrangement being whenever a transversal passes through two lines, is what we call corresponding angles. Again, like alternate interiors, these are going to come in pairs. Okay? Okay, so the pairs of corresponding angles are going to be identified here as 2 and 6, 4 and 8, 3 and 7, and, okay, 1 and 5, which I seem to have forgotten. Oh, there's 1 and 5. 1 and 5. So 1 and 5, 3 and 7, 2 and 6, and 4 and 8 are corresponding. Now, how would we describe these? How would we describe these? Well, for one thing, all these pairs of angles, as you can see, are on the same side of the transversal. 1 and 5, 3 and 7 are, of course, on the left side of the transversal. 2 and 6, and 4 and 8 are on the right side of the transversal. So that's the first order of business. But, okay, they're not adjacent to each other. Okay? 2 and 6 are on opposite sides, are on the same side of the transversal, but they are not adjacent. Okay? And they are comprised of an interior angle of 6 and an exterior angle of 2. So, corresponding angles, the definition so we can spot them when we need to, are identified as the angle pairs formed by a transversal one interior, one exterior, non-adjacent on the same side of the transversal. That's a lot, okay? But that's as definitive as we can get with our definition of corresponding angles. On the same side of the transversal, one interior, one exterior, non-adjacent. So therefore, with the figure that we see here, the only angles meeting that criteria are 2 and 6, 4 and 8, 1 and 5, 3 and 7. You need to understand these definitions: interior, exterior, transversals, corresponding angles. Okay, let's move on now, okay? Now we're going to talk about the corresponding angles formed when the lines that are given are parallel. When the lines given are parallel, okay? All right? When the lines L and M, when the lines L and M are the given lines, and they are parallel, and the transversal cuts through them, you're going to have the special case of what's happening is the corresponding angles are going to be congruent. Okay? This is our postulate 3-1, the first postulate in chapter 3. The postulate stating if a transversal intersects two parallel lines, again, parallel needs to be stipulated, then the corresponding angles are congruent. We'll actually illustrate this pretty simply in Sketchpad, okay? But for now, we just need to accept it that when parallel lines are cut by a transversal, all corresponding angles are congruent. So, I did construct these in Sketchpad, and I have illustrated that those angles in the position designated by corresponding same side interior, same side of the transversal, non-adjacent, one interior, one exterior, as we defined previously as corresponding, they are going to be congruent provided the lines L and M are parallel, which is going to be the same thing for the other sets of corresponding angles, okay? So since L and M are parallel and G is the transversal, and since the one angle has been identified as 120, okay, we're going to pick up all these pairs of corresponding, okay? Now the fact of the matter is, if I know one angle, that being 120, I can find every other angle in this picture. Okay, so since angle 1 is 120 and angle 2 is supplementary to it, it must be 60. Okay, next I'm going to ask, well, how do I know angle 3? A couple ways actually, but you could see that angle 3 is vertical to angle 1 and therefore equal to 120. Okay, what about angle 4? Well, angle 4 is the corresponding angle, angle 2, so it is equal to angle 2, okay? And angle 2 is 60, so angle 4 is 60, okay? What about angle 5? Angle 5 is vertical to the 120 over here as we point to it, so therefore it is 120. You could also say it's corresponding to number 3 or supplementary to angle 5. So there's a number of ways in which we could identify what the measure of these angles were, okay? We're going to get one more theorem. A theorem is a statement that can be proven true, okay? We're going to illustrate that when two parallel lines are cut by a transversal, again, that statement is here. Here's the parallel condition as stated, okay? When two parallel lines are cut by a transversal, we're going to show that our alternate interior angles are another pair of congruent angles. So the alternate interior angle theorem, which is better to remember it by than theorem 3.1 because it kind of says exactly what it's about, says if a transversal intersects two parallel lines, then the alternate interior angles are congruent. Okay? So when a transversal intersects two parallel lines, we're going to know from this picture 4 and 6 are congruent and 3 and 5 are congruent because they are the alternate interior. Okay? We'll look at a proof of that in the next, and we're going to start looking at proofs more and more now. Okay? So in a proof, we end up giving you some bits of information, and with that information, we want to be able to move towards the statement that we're asked to prove. Usually the proof will involve a picture as well as your given information and the information asked to prove. All proofs that we're going to do are going to have two columns, or what we call two-column form, a statement and a reason. Okay, we begin with the given information, and the reason, of course, is that that is given. Then we try to move from that given information with maybe 1, 2, 3 steps, or maybe more, to come up with this final information. Well, one thing we know for sure, okay, and that was built on the postulates of the corresponding angles, that 3 and 7 are corresponding. 3 and 7 are corresponding. And if we're going to try to link 3 and 5, we got to try to find some preliminary link to link an upper pair with a lower pair, and that's going to come through the corresponding. So we're starting with 3 and 7 being equal because, why? Well, because they're corresponding angles. Okay? But then, what are we trying to get to? 3 is congruent to 5. 3 is equal or congruent to 5. But we should know a relationship that is stated here. Okay? 5 and 7 are vertical, right? 5 and 7 are vertical. Okay? They're vertical angles. They're easy enough to spot. We have vertical angles all over the place here. And vertical angles are always equal. Well, look what we have. 3 is equal to 5. 5 is equal to 7. So therefore, 3 must be equal to 7. Or 3 must be equal to 5. Since 3 is equal to 7 and 7 is equal to 5, we can preclude that 3 is equal to 5 by the transitive property. Okay? All right, we're going to cut it off at this. Okay, that's probably long enough for this. And we're going to come back to the second part of this slideshow with another video, which will usher us into the theorems of section 3.2. Okay, so that'll do it for now. Don't forget, review this again if you need to. The whole thing about this was identifying the angles here and naming them, and the relationship of corresponding being equal, and now alternate interiors being equal. Okay, that'll do it for now. Okay, so watch this along with the slideshow so that